All right, so our next module, we will talk about the firewall networks, or in short, we call it FireNet. So first of all, why do we need the firewalling? That could be like your security posture dictates that you want security, end-to-end security. That's why you need the firewalling. Maybe that is a compliance reason. Maybe some of the audits requirement is to have the firewalls. And now, since you know, you need the firewalls, then where do you need the firewalls? Do you need it only for east-west traffic or north-south traffic or everywhere? By the way, the industry standard is east-west traffic is for everything, meaning if you are between the VPCs, VPC2 in one region or one cloud to another region or another cloud, or from on-prem over to the cloud. So anything that is under your control is considered as east-west. North-south is a traffic which is destined for the internet, going into the internet or coming from the internet. That is a traffic which is called a north-south traffic. So question over here, if you need the firewalls when you are communicating between the VPCs, when the traffic or application is going to the internet, you wanted to make sure the traffic is first inspected by the firewall and then go out there. You wanted to make sure when somebody is sending the traffic from on-prem environment and try to reach some of the important application, that traffic has to go through the firewall network as well. And when your partners are communicating, you wanted to make sure that traffic also getting inspected. What about if you wanted to go into a different region or maybe a different cloud, Azure, GCP or something, you need inspection over there as well. All this inspection, everything is being done through the Aviatrix controller and the gateways which are in the data path over here, right? So now let's go into details, the problems of inserting the firewalls in cloud networks, right? What are the different challenges which different vendors sees that, right? So first of all, from the vendor perspective, the challenges are the vendors have just repackaged or repurposed the same software which has been utilized for on-prem. They now made this thing available for the cloud environment as well, right? So it basically lacks the understanding of the cloud native constructs. What are the challenges in the native constructs? How you can send the traffic over to them. And then what they say, hey, Mr. Customer, we are expecting you to route all your traffic over to us, or whatever traffic you want to get inspected, just send it to us and we will do the rest. So basically what they're doing, they are lacking in understanding of the cloud networking and their challenges over there. From the cloud provider perspective, they wanted to promote their own firewalls, right? Even though they are just the basic layer 4 firewalls, they wanted to promote that. And then again, same mantra over there, right? For example, we expect Mr. Customer you to go and figure out the routing piece. We are not going to redirect the traffic. Or if we are going to redirect the traffic, then we are going to redirect the traffic like all or nothing, like a route, a static route. And by the way, that is static route you have to put in yourself. You have to go in there and create the static route and redirect the traffic over to the cloud, over to the firewalls. And for the cloud providers, they basically don't provide you the east-west traffic and then the traffic from the on-prem branches, site users. All these kind of inspection is going to be pretty limited from the cloud provider perspective. What about from the customer? Customer has to manually figure it out, everything, like the routing piece, the troubleshooting, the visibility, everything. And on top, they have to manage the IPsec. They have to manage the BGP. If they don't want to manage the BGP, IPsec, and SNAT, which is a source NAT basically, then they have to compromise on the throughput, right? And we will talk about it. And the throughput is going to be reduced up to like 500 megs, right? So let's look at the different solutions from two major cloud service providers like Azure and AWS. First, the Azure. Azure has two different solutions. The first solution is with their own firewalls. So here, if you have two VNets and they wanted to make sure their traffic is always going to be inspected, what they do, they create they deploy the Azure firewalls in the hub VNet. And from here, they are using the UDR and then pointing towards the firewall as a next hop. Okay, that's fine. The traffic gets to the firewalls, and the return traffic usually does not take the same route back. It takes the fabric route. So if it's doing something like this, then you have to enable the source netting over here. So challenges in this kind of approach is, first of all, this is just a layer 4 firewall. If you are looking for DPI, if you're looking for intrusion detection or prevention mechanisms, layer 7, then that is not being provided by the Microsoft or Azure firewalls in there. All these route manipulation, the UDR management, that's what you have to do on your own. High complexity to manage the changes in the firewall. And if application requires the full visibility of the source, sorry, that is not possible because I have to enable the SNAT over here, right? One good thing which the cloud provider provides, like Azure provides, is enable the SNAT by default on Azure firewalls only. Look at the third-party solution. In third-party solution, you can bring your own firewall like Palo Alto's, Checkpoints, Fortinet, or whatever you want. And then the solution is pretty much the same over here. Now you have the luxury to utilize the layer 7 functionality. But the problem of SourceNet still remains the same. You have to enable the SourceNet this time. This SourceNet is not going to be enabled by default. You have to enable it manually over here. And these firewalls, it's going to take long and inconsistent failover time when you are doing the HA between them. It's difficult to manage. Again, the UDR management, the static routes which you are going to point towards the firewall, you have to manage everything on your own. The problems of high complexity to manage the changes and the source netting is still going to be there. So no matter what native solution you are going to pick, you have to do some compromise if you want to go with all native. What about AWS? What AWS provides? Similarly, AWS has two different flavors as well. The third flavor which they have is some type that like 99% of the world does not even use it. So we are not going to discuss the third solution over here. So the first solution is regarding the VPC attachment. Here, since they have this transit solution, which is provided by the transit gateway, they say, okay, why don't I attach a security VPC using the VPC attachment so I can get the maximum throughput, which is, by the way, a 50 gigs of throughput over here. And then I can put my firewalls over here in that VPC and then manage everything through it. Great, that is great. Yes, you can get the maximum throughput of the firewalls. If the firewall provides you 6 gigs, 10 gigs, you can get all the throughput of the manufacturer or vendor. But you can have this solution only in active standby. And by the way, this active standby will be only in a single AZ. You cannot have the AZ level of high availability, right? AZ level HA is not available over here in this particular kind of design. So you are paying for something which you are not even using as when we are talking the active standby, right? So the routes over here, you have to manage all the routes here. So which VPCs wants to communicate, needs inspection, the TGW routing table, this routing table, everything you have to redirect everything on your own. So again, the complexity is there. It cannot scale. You can have maximum of 2, out of which only 1 is active at a time. And again, long, complicated failover times over here is also a concern with this model. So second option, which they provide, it's called IPsec VPN model. This model, this says, okay, you are looking for something like active-active, we can provide you active-active. By the way, we can provide you active-active in different availability zones as well. So what's the catch here? The catch is you have to enable, you cannot utilize the VPC attachment like this in this model. You have to go with the IPsec. And remember, we talked about the IPsec. Like when you need ECMP, you need BGP. When you need the BGP, you need the IPsec. And as soon as you enable the IPsec, you are limited to 500 megs of throughput, because the maximum throughput which you are going to gain or get from this IPsec tunnel is 1.25 gig. And since the traffic traverses twice, this traffic is reduced by 2, and approximately you are going to get about 500 megs of throughput. So what are the challenges in this one, right? The challenges in this model is you have to manage IPsec, you have to manage BGP, you have to manage the source SNAT over here in this scenario too, because TGW has to send the traffic back to the same firewall. If it does not know where the traffic is coming from, then it can send it to anybody, and then that would bring the asymmetry in the picture. That's not what you want, right? Yes, 2 different solutions by Azure and AWS, but both solutions are not ideal solutions. Even in this solution, you are managing all the routes, static routes and everything. So what is a right solution over here? Or what is a solution which can overcome all these challenges which we have been talking about it? So let's introduce Aviatrix Firewall Network. Aviatrix Firewall Network, you have seen up till now, you have seen this picture many times in transit, right? You have spokes. Doesn't matter whether you are dealing with the VPCs or VNets. You have spokes, and under spokes, you have spoke gateways, and you have transit, or you can call it the hub, VPC or VNet. Over there, you have some transit gateways over here, and you are connecting them together all the way. So this is Aviatrix Transit. What we are adding here, another piece, which is the firewalls over here too, right? So these firewalls sits right here in the transit. So you can now utilize the full performance of the firewalls. So you are not limited with 1.25 gigs of throughput, or maybe the better way of saying it is the 500 megs of throughput. You're not managing the IPsec here. You are not managing BGP. You don't have to worry about the source NAT. So applications which require to see the original source IP, they will be able to see that thing. Who is doing all the magic? These transit gateways. Those becomes the FireNet gateways as well. They are doing the magic. They are retaining the session stickiness and everything, and then they are providing the hashing right here. So you can actually scale with no compromise in the visibility. We support the major firewall vendors like Palo Alto's, Fortinet, and Checkpoints. So from the architecture perspective, that's how it's going to look like, right? And then irrespective of the cloud, you can have the VPCs and VNets and hub and spoke topology, and then you can have AZ level of redundancy in here as well. And by the way, in each availability zone, you can have up to 10 firewalls over here. And if this solution is not good enough for you, then you can create another firewall network like this with other VPCs and the VNets, and you can scale it in that regards. But I have not seen or met any customer who requires more than that many firewalls. Okay, and the throughput again, we've been talking about the Aviatrix Transit that can provide you a 70 gigs of throughput, right? So that's what we can provide you. So what about the natively, how we can help the native constructs? Native constructs have a lot of limitations when they are inserting the firewalls. Is there anything Aviatrix is helping with the native cloud constructs? The answer to that question is yes, Aviatrix is helping over there as well. In this particular section, I'm going to talk about the AWS TGW FireNet, right? So how Aviatrix is helping AWS TGW types of firewall insertions. Here, all these VPCs are connected to the TGW. That's a native construct. And with the TGW, you have another attachment, like a 50 gigs attachment, to a transit VPC, or you can call it a security VPC over here, right? That's where your Aviatrix gateways are sitting over here. These Aviatrix gateways this time becomes just the FireNet gateways because it's not providing the transit functionality from the VPC perspective. It's providing the transit functionality from the on-prem perspective too. So this becomes the transit plus FireNet gateways. And behind these gateways, there are your firewalls. Now, these links are not IPsec links. So you can have the maximum throughput if a vendor tells you that, my cloud firewall can provide you 10 gig of throughput, then we can provide you a 10 gig of throughput through these links, right? And you're not managing BGP here, you're not managing the SNAC, nothing. So all the problems of the native solution is gone, except there is still something like end-to-end encryption is not available in this design. And on top, you don't have the visibility, complete visibility. You have visibility only over here at the transit level, but the VPC level visibility is not there. And again, I'm going to mention that Travis is going to show you, like, what do we mean by the visibility when he's going to talk to you about the Copilot. So this architecture is going to be scale out, and we are going to provide you the load balancy in an active mode. And we do have a concept of security domains. What do we mean by that? Let's discuss this thing in the next slide. But prior to that, these are the things which I just mentioned. Like, we don't have to do any kind of IPsec, manage the BGP, and we maintain the session stickiness. Customer does not even have to do any kind of route manipulation, like redirection of the traffic. It's our responsibility. We do the orchestration of those routes as well. If you are looking for something like a zero-touch VM series deployment, like a Bootstrap, you can do that too. There are customers who wants to manage the firewalls using the panorama, right? Because that's what you guys are used to do it. If you have a couple of firewalls, that's okay. You can manage individually. But what about if you have a lot of firewalls? You might have firewalls on-prem as well. You want it to manage through the same panorama. We do have integration with the panorama too. We send the routes to the panorama, and panorama is going to program those routes into the into the firewalls. Okay, so I talked about these security domains concept. So what is a security domain and how it's important when we are talking about the firewall networks? Security domain is providing you an isolation. So basically segmentation between the VPCs. If you don't want the prod VPCs, a set of prod VPCs to communicate with the dev VPC, then you place them simply in two different domains, security domains. So now by placing just dev VPC into dev domain and prod VPC 1, 2, 3 in prod domain, they won't be able to communicate with each other at all, right? But the VPCs, all these VPCs, prod 1, prod 2, prod 3, all part of the same prod domain, they should be allowed to communicate with each other because they are part of the same domain. So you are doing nothing but the grouping of this VPCs who has the similar security policies. So security domains, what kind of different security domains you can create? You can create the security domains like the FireNet security domain. You can create shared services security domain. There are some default security domains which we can create, like edge security domain. The edge security domain is something which is providing you a transit functionality between multiple clouds or maybe multiple regions. Okay, so this is all good, but what about in a scenarios like when we wanted to segregate the domains, but there are times when we wanted to provide the communication between them too. So this looks kind of weird. Like at first, I wanted to make an isolation between them, and then now I wanted to make sure these two domains talks to each other. What would be that scenario? That will be a scenario when you want them to not talk to each other directly. They will be allowed to talk to each other only through the firewalls. That's when you wanted to provide that kind of communication. And how we are going to make this thing possible, that thing is going to be made possible using another concept, which is called a connection policy. So now prod wants to communicate with dev, then initially we don't have any connected policy, no connection policy right over here under the prod domain, right? Under this prod domain, we don't have any connection policy over here, so they won't be able to communicate with each other. But now I want them to talk to each other, and I want them to talk to each other through the firewalls. Then what I have to do, I have to add these two domains. The prod domain under the dev, I am putting the prod domain and then the FireNet domain, so they should be able to communicate with each other, not directly, but only through the firewalls. So this all the manipulation of the routes and the redirection that is being handled by Aviatrix here. Okay. So natively, this is the solution that we have for native. If somebody wants to, somebody wants to utilize this without the troubleshooting tools and then the visibility and encryption, that's one solution for native AWS. For native Azure, this is what we have, right? So you can have a transit right here, and you can create a transit FireNet with the firewalls over here with our gateways, and you can use the native peering, the VNet peering over here. Here we are going to manage all the UDRs, and we will point all the UDRs over here towards our gateways. On the gateway, we will make sure the traffic is redirected towards these firewalls over there. Yes, this solution is good, but again, this solution is not going to provide you end-to-end encryption, and it's not going to provide you the visibility at the spoke level. And again, troubleshooting too. So what about if you are in multiple region and you are in multiple cloud? What solution do we have? There are times when the cloud IT, right, the central IT, they have an architecture like this. They wanted to make sure your direct connect or your express route is terminated over here, right, on the transit. And here you have all the spoke VPCs. But there are certain other BUs. They say, hey, the firewall rules which you are writing or the policies which you have for your VPCs, I don't like those, right? I wanted to control my own firewalls. How are you going to do this thing natively on the native, using the native constructs? That is a disaster. So what you can do, you can have environment number one like this, right? You can say, okay, since you are business unit one, you can have your own VPCs, you can have your own transit, you can have your own firewalls, no problems. What about environment number two, environment number three? By the way, my environment number three, I want this thing to be completely sandbox environment, completely isolated. I don't want this to talk to any of the other environments. But all the other environments, I want them to talk to each other, right? By the way, this guy has no firewalls whatsoever. Can I have an architecture like this? Is there anything which can provide me that kind of repeatability and scale? Then the answer to that question is yes. By the way, this thing all happens inside a single region. So there is no dependency on how many constructs you can reuse and how many times. So everybody has their own, and you can multiply it as many times as you want. And everything is now connected to the central IT, where you can have access to the on-prem world as well. All right, so multiple region and multiple cloud. If you wanted to do the right architecture, then this is the right architecture where Aviatrix controller can be in any cloud. Doesn't matter whether you are in AWS, GCP, or wherever. And then you have your gateways, Aviatrix gateways everywhere in all the spokes. And here is your transit. From on-prem, you also have the encryption from on-prem over to the transit. So end-to-end encrypted with visibility, troubleshooting, and repeatable architecture. But what about if the customer says, no, I wanted to go with the native constructs, right? So I wanted to use a TGW and the native VNet peering. Can Aviatrix support that? then the architecture is going to look like this. And then the answer is yes. And again, I've been talking about the same thing over and over, then you are going to lose a lot of functionality and capability. But this is the decision which you have to make.
So I'm going to continue on with some of the Aviatrix feature functionality, private S3, site to cloud, Cloudwin, and user VPN. Each one of these use cases, along with all of the other capabilities that you've seen, are all managed through the controller. And all of these bits of feature functionality came about because early adopters in the cloud discovered that they needed these capabilities, right? So as those capabilities have been developed, we rolled them into the controller. And I just want to give you a quick overview of these 4 features, and then also let everyone know on docs.aviatrix.com and on our community site, but mainly on docs.aviatrix.com, there are FAQs for all of these, right? That go into a lot more detail than I'm going to cover here in the next few minutes. So what is private S3? So why do people use S3? Enterprises like S3 because it's cheap storage, it's quickly available, and there's plenty of it, right? So they'll typically set up a scenario like you see on the right, where they'll have a direct connect link up into corporate S3. But users inside of the organization shouldn't be using that direct connect link to access their own private S3 buckets. So I'm going to tell you what that means in a minute. So if you have corporate S3 buckets and they're connected through direct connect, and I'm inside of your environment, there's a huge data exfiltration risk. So if I'm a developer and I know a bit about S3, I can create my own S3 bucket in the same region as the corporate S3 bucket, and from on-prem, I can copy anything I want out to it, right? And this is because of the way S3 is designed. It advertises all of its public IPs through the direct connect to on-prem. So as a user, if I'm a bad guy inside of your network, I can take whatever I want out, right? So this is a risk, right? And a lot of InfoSec teams have kind of identified that, and this is what private S3 does. So what we allow you to do is to control or limit what S3 buckets can be accessed from on-prem through the direct connect link. And that's very powerful, right? So companies that use things like Snowflake or any other type of ETL data load, if you're putting sensitive data out on the S3, you want to make sure that it's secure. And this is, I think, the only solution in the industry that does anything close to it, right? And the more data that you send, you can put multiple gateways to actually load balance that traffic to S3. So it can handle massive amounts of data. And again, in the S3 FAQs on the doc site and in the community site, we've got some collateral there that describe why it's important, some of the data exfiltration scenarios, and how this works. So I recommend anyone interested in security in S3 to go out there and take a look. And this just goes into a little bit of the details. So any files that you want to transfer up into S3, this is what it's for. If you're looking for securing egress at the VPC level, that's where the FQDN egress functionality comes in. So 2 different things. This is for data transfer into S3. The other is for network egress for your applications. Site to cloud, this is your IPsec capability. Why would you need it? You need to connect on-prem DCs, you've got partners, you've got remote branches, IoT, if that's what you're doing. It supports NAT, it's got active-active and active standby failover capabilities. This workflow, again, directly from the controller, follow your nose workflows numbered to set up an encrypted connection anywhere you like, right? And again, when you set up these site to cloud connections through our gateway using Aviatrix, you're going to have full visibility on what's going on there. That's really powerful. So on one end is one of our gateways, standalone or transit, and on the other end can be any type of device that supports IPsec. And it also supports overlapping CIDRs and TCP and UDP tunnels. This is just a diagram of what some of that may look like. So if you've got this, could be multi-cloud, it can be on-prem, it could be using Aviatrix Cloudwin, which is our high-performance encryption device that can be placed in colos or on your site. So this just kind of shows where it can be used. And some of the connectivity options, HA capability, right? So you've got multiple tunnels, you know, through the gateways, through the spoke VPCs, and through the transit, right? This is just another view of the transit. Let me make this bigger. There we go. So Cloudwin, let's say that you're kind of on the way in your cloud journey. You've got some, and this is typically what we see. We've got customers that they've built some really cool applications in the cloud. They've got a lot of sites dispersed geographically. They've got a lot of Cisco gear installed in those sites, and they want their remote sites to connect to cloud applications, right? So what we've done here is we've provided a capability from our controller to connect directly into that Cisco infrastructure and connect it into the cloud, right? So we call it Cloudwin, right? Easy to deploy, frictionless, and one person or team of people sitting at the controller can affect this change globally, right? There's no trips, there's no rip and replace. You know, there's no one else that's doing this. And another thing, we actually worked with, I think it was during reInvent at AWS, they introduced something called, oh, it's escaping my name, but it's a backbone feature. And we actually ride the AWS backbone. So if in Singapore, it's called Cloud Accelerator. And if you had a connection in Singapore, you had Cloudwin hooked up into it, it would either take this scenic route and travel all over the place, or it would ride directly on the AWS backbone. So that's another key capability feature of it. This is another topology view, kind of what it looks like. Again, what I described earlier, you can do this directly from the controller, right? The magic happens from one place, one central management spot. And then you can configure VPN and BGP settings, and there's an editor, there's a text editor that we include in the controller, and you can test it out. But basically, it speaks Cisco iOS, and it gets its hooks into your remote device and programs it. All right, user VPN, another key capability that we've got. You know, essentially, it kills the bastion host model, right? So using our VPN gateways, your users can connect directly into the cloud resources in a secure way, in a way that your organization can observe what they're doing and give you a very high level of control over what accesses what they can hit, right? This is what it looks like, and again, you know, you can see our MCNA pattern evolving there. We've got a cloud access layer, transit, and applications, and down here on the bottom, you've got sorry, I just want to get all that out there. Down here on the bottom, you've got partners, contractors, employees, different IDPs, right? So whether they're using AD, SAML, Okta, or Duo, right? The IDP authenticates them. They log in through the VPN client. The VPN gateways determine what they can access, and then they're off to the races, right? And all of this is highly secure, and it allows you to enforce and design some pretty elaborate isolation rules, right? So you can say things like, You know, I want my contractor developers only to access resources in this VPC. However, I want my employees to be able to access all of them or a subset, for example, right? And we've got an Open VPN client, and with that Open VPN client, you can download from our site. It's got integration with all these SAML providers. Here's another view of what that looks like in a multi-cloud environment. So again, you know, all of this infrastructure is managed through the controller, but you've got all of this capability where you've got different groups of users that need secure access into cloud resources and different providers, and you're controlling it in a very secure, unified way. There's no scripts, there's no, you know, there's no DevOps, there's no code. This is all happening directly through the Aviatrix platform.